our next task is the laser beam that's used to detect the oscillations of the cantilever comes straight down the center of this tube, strikes the cantilever, which is at a little bit of an angle, comes up, goes through a lens on the bottom of this head and into the detector. So first we're going to line the laser beam. Our task is to align the laser beam onto the cantilever. And in order to do that, we need to bring the whole assembly far enough down that we can see that alignment with the optical microscope, because by the usual position that this is in is too high for that. So the AFM controller, however, is set up that it won't allow you to lower the head if it thinks you've already broken the cantilever. And the way that it thinks that you've broken the cantilever is if there is no beam hitting the detector at all. Over on this screen it shows the results of the detector. This is a 4-quadrant detector, so it's kind of shown schematically here. There's actually 4 photodiodes. And down on the bottom is shown the sum of all 4 photodiodes. And right now you can see that there's a bar graph that's registering nothing, so that the laser beam isn't hitting that at all, because right now it's not hitting the detector at all. Above that is the display of where the beam is hitting on the 4 quadrants, and right now it's not hitting at all, so you can't see much. Above that is an indication of the RMS oscillation amplitude that the cantilever is bouncing up and down with, which again is 0 right now. And here's the vertical deflection amplitude, which is essentially the DC offset, which ordinarily for tapping mode that should be reading 0. But all this is meaningless right now because there's no laser beam hitting anything. So in order to lower the assembly, we have to get things approximately aligned so that we get some sum signal, some non-zero sum signal, and then the software will allow us to lower the AFM head enough so that we can then look through the microscope and do the final alignment. So, in order to do the rough alignment, first make sure that it's high enough. Now actually, before we get too involved here, we should load a standard setup file. So I'm going to scope profile, and it brings up all these different profiles, and the one you want or mapping is called Walters 10AM. So make sure that that's highlighted and then click on Load Master. And it has this delete confirm. It says your changes to profile Walter TP will be deleted. That's because as you're going along and you're changing where the scan is and what the size is, it keeps track of all of that so that when you boot up the computer the next time, it will bring you back to exactly the same point that you left off at. But if we're starting fresh, we don't want to be at exactly that same point. We want to be at the standard start fresh point. So we say, okay, I don't mind deleting all those changes. I want to go back to the standard point. Okay. Now, in order to do this rough alignment, which we need to do before we can even look through the microscope to do the fine alignment, I need to put in this slide so that I'll be able to see the image of the beam missing the cantilever, as it were. Before I can put the slide in, I want to make sure that the whole assembly is high enough so that I can slide the slide in without smashing the cantilever. So I'm going to click on this red up arrow icon in the upper left to raise the cantilever, and you can hear the noise, the motors raising it. So I'm going to go in, and I still have to, because it raises it by 1 millimeter by default. And so I carefully place the slide down, make sure the surface, and then slide it in horizontally. And I actually want the laser beam to be above the sticky part of the slide rather than on a sample or on the glass slide itself, because I want to be able to see the laser beam. Now I think I describe more than be able to see it. But if I look from the side here, I can see a little dot on the double-sided sticky tape. The dot is there because the laser beam is missing the cantilever. If the laser beam were completely hitting the big substrate, then there'd be no dot there. So turning this knob that's labeled X moves that dot of the laser beam in this direction. Turning the knob that's labeled Y moves it in the opposite direction. Right now the laser beam might be at this location. I'm going to start by moving it backwards in X until I see the dot on the tape disappear, which means that I'm moving back onto the cantilever substrate at some point here. Then I'm going to move it back out until I just barely see it reappear, so now I'm presumably there, and then I'm going to move back and forth in the Y direction until I see a red dot appearing on this screen here. The laser beam that gets reflected off the cantilever, as I said before, comes up into the detector, but actually before that, part of it gets split off to be shown on this screen. So first, first I'm going to move the beam back that way until I see it disappear off of the cantilever. Then I move it back this way. I see it disappear off the double-sided sticky tape. Then I move it back this way until I just barely see it reappear. And then I'm going to move it back and forth in Y. And hopefully I'll get a little bit of an indication there. Okay. If for some reason I don't, that means that I'm probably too far in that direction in X, and I need to move further in this direction and then move back and forth in Y. But you've got to move it around until you get this little gear, and you shouldn't have to move very far. And it usually works of starting again by moving it that way until the dot disappears off the double-sided sticky tape, then just bring it side to side until I get a window here. So here's the recipe. First I'm going to move it in that direction until the laser disappears off the double-sided sticky tape. There, it's gone off the double-sided sticky tape. Now I'm going to move it in the opposite direction until it just barely reappears. There. Now I'm going to move it left and right in X and Y until, well, actually I didn't need to, but when I move it left and right in X and Y, you can see that red dot appears and disappears. So I just need to get that red dot to appear, and now when I look over at the screen, it doesn't come into focus very well, but you can see there's a non-zero indication on the sum signal. Now that I've got a non-zero sum signal, it will let me approach, and so I can lower this as much as I want to. I don't want to crash into this double-sided sticky tape stuff, so I'm going to very carefully slide that out of the way. It's done its job. It was just being a screen for us to observe the laser beam on. To lower the tip at all, first we have to do a rough alignment of the laser beam onto the cantilever so that the sum signal, that bottom horizontal bar graph, becomes equal to at least half or so. So I've slid a piece of white paper very carefully underneath the cantilever, making sure not to hit the cantilever as I do that. And if I look from this angle up here, you can see it looks very bright in this camera. There's the red dot of the laser beam hitting the white paper as it's missing the cantilever. So I'm going to use these two controls, X and Y on the top, to move that beam around in approximately. Right now, the beam is roughly in this position, so I'm going to start by moving it back this way until it strikes the cantilever surface. At that point you'll see it disappear off the white paper. Then I'm going to move it back out this way until it just barely reappears. Then I'm going to move it in this direction, back and forth in this direction, which is the Y, until I see a red dot appear on that screen. So here we go. First I'm going to start by moving it in that direction, which corresponds to turning the X knob clockwise, and you'll see that it disappears as soon as it hits the cantilever substrate. So there, it's no longer there, it's even more completely obscured. It's completely off the paper, basically. And now if I move it back in the other direction, this way, by turning X counterclockwise, there it's just barely hitting the paper. Now I'm going to knob forth until I see a spot. Now actually you can already see a spot, but I want to try to make that spot as big as I can get it by turning the Y knob back and forth. So that's pretty good. I've got about a reading of 1/2. That's maybe not quite good enough. So let me, right now you'll notice when I'm moving it back and forth to try to get that spot as bright as I can, which corresponds to the biggest reading possible, the sum bar graph. Now I want to lower the AFM head so that I can look at the alignment through these eyepieces more accurately. So first I'm going to carefully remove this piece of white paper. And I have to be very careful so I don't ding the cantilever as I do that. Then I go to the software and I click on the green down arrow here. There are options that appear in this dialog box: manual, automatic, and quit. You almost never want the automatic. We'll discuss the one circumstance in which you want that later. So for now we'll choose manual. And now there are 4 options: withdraw, approach, OK, and cancel. I'm going to click on the approach. And when I click, there's down. There are stepper motors built into this assembly that are moving this whole head down rather slowly. So I'm going to look from the side and just move it down. I don't have to move it down really, really far, but I've got to get it fairly close to this stage so that I can see it with the optical microscope. Next, I need to turn on the illuminator back here, which brings light through this optic fiber through this top view microscope, hits a mirror here, and then bounces it down. So you can't see it very well, but that allows me to see through these eyepieces. Okay, so this is the view looking through the eyepiece of the microscope, and you can see the cantilever protruding into the field of view just barely. Now, if I turn off the illumination, you can't see much right now, but if I move the laser beam around, you can see there's the laser beam, and I'm adjusting the X position of the laser beam there, and there's the Y position. And so basically I just line up the laser beam on the end of the cantilever like that. Now if I have it too far to the left, then too much of the laser beam is spilling off the cantilever and I'm not going to get a very strong reflected signal. If I have it too far to the right like this, then the laser beam is not hitting the part of the cantilever that moves up and down as it goes across the sample surface. So I want some kind of compromise, so right about there, with not too much of it is spilling off the end, but it's not too close to the base either. I'm now going to adjust the Y direction, but not the X. So that's the direction in our previous view, kind of up and down in the microscope, so as to maximize that sum signal. So I'm going back and forth, trying to get that sum signal to be absolutely as big as it can, which is usually around 2, slightly bigger than 2 right now. This adjustment in the other direction, you can do that roughly by looking through the eyepiece, but that's the one where you're trying to maximize the sum signal more than trying to align it by eye. Now that we've got the laser beam hitting the cantilever properly, the reflected beam is coming up off the cantilever and going through the lens on the bottom of this head, and we now need to align the detector so that it is centered on the laser beam, so the laser beam is hitting the center of the 4 quadrants of the detector. And we do that with these 2 knobs here. This one is labeled Y, and it's got a circle pointing counterclockwise here, meaning that if I look back on the computer screen at the detector window, see the little red dot? That represents the position of the laser beam on the detector. So if I turn that control in the direction counterclockwise, it would tend to move it in the plus Y direction, which is up. So that's not what I want to do. Instead, I'm going to turn it clockwise, and you can see right now it looks like it's moving in X. That's because that knob actually moves it along a line that's mostly Y but has a little bit of X component, and it's outside the range of detection. So, but if I keep on moving it, it will start to go down in Y, there. And now I move the X knob to bring it to the center of the crosshairs. And I move, sort of play back and forth between the X and the Y, and just get the little red dot right at the center of the crosshairs, like so. Now the laser is aligned onto the cantilever, and then the detector has been aligned with the laser beam. The next step is to tune the cantilever.